Hello and welcome to my video. In this video, I'm going to talk about numbers in different bases, but more specifically numbers in base 10, binary numbers in base 2, and hexadecimal numbers in base 16. Binary is the name for numbers that are in base 2. And what that means is it is simply the number system that is comprised of only the digits 0 and 1. And since base 2 is only using these digits 0 and 1, it is perfect for representing bits, since bits can only be zeros and ones. And throughout your computer science career, you will hear binary numbers being used all over the place. So it is very important to know them. So let's start by looking at numbers in a base that we know, and that is going to be decimal or numbers in base 10. And numbers in base 10 or decimal numbers are numbers that are going to be comprised of the digits 0 through 9, or simply the counting numbers that we have used all throughout our life up until this point. And how they work is once you run out of digits to use, you are going to add a new place to hold digits, and you're going to increment the digits there. You're going to start at, well, not 0, but you're going to, because technically that was already at 0, so you're going to start that at 1, or increment it up to 1, and then continue on incrementing, or reset this back to 0, the original starting digit, and then you're going to increment back through, and once you hit this back up to 9, so once we're at 19, we're going to go up to 20, all the way up to 99, where we would add another digit, increment that to 1, and start counting back and reset both of these digits, and then start counting again from the first digit. But how does that look like for binary numbers? So with binary numbers, we still have the digits 0 and 1, but now I have run out of digits. So what do I do? Well, just as in the case of decimal numbers, in the number 9 going to 10, we are going to add a digit and then reset the starting place digit to 0. So that will be the number 2. And then I could increment that first place again. So 1, 1 would give me the number 3. But now, again, I've run out of digits to use. I've used up ones in both these places. So I need to add another place and then reset both of the places to the right, and that would represent the number 4. And then I'm going to start incrementing from the 0th, or from the first place again, representing the digit 5. And well, I've run out of digits here, so now I'm going to, just as if I had gone from 109 to 110, I'm going to increment this one and then reset this one. So let's do that. We go to 1, 1, 0, which is going to represent 6. And then we have 1, 1, 1, which would represent 7. Well, we've run out of digits again, so we need to add 1. Trail it with those zeros. That's going to represent 8. Then we're going to increment the last place, which will represent 9. Well, I've run out here, so I need to increment this one and then reset this one. So let's do that. 1, 0, 1, 0 will give me 10, and then 1, 0, 1, 1, since that first place is now back to 0, I can increment it again. So I get 11. And then you can keep doing this incrementing, so on and so forth, until you get up to 99, which is going to be 1, 1, 0, 0, 0, 1, 1. In binary, you can just trust me on that one, and that would represent 99. And then for 100, well, we are out of places here, and we're out of places here. Our next available place is here. So we are going to, well, copy there, increment there, reset over here to represent 100, 1, 1, 0, 0, 1, 0, 1. Now, since we've freed up this first digits place, we can increment it again here to represent 101. And then it's just going to keep counting off into infinity. You can represent any number by just adding more and more bits as you need to the front. And we will learn how to more elegantly convert these numbers from decimal to binary, and then from binary back to decimal. But we're not going to do that in this video. We will do that in another video. As you can imagine, with binary, if you want to represent a very large number, you will have to have a lot of bits to represent that number. So, when really, really large numbers are to be displayed, most of the time, they are displayed as hexadecimal values, such as when you see addresses in memory. Since there are very large numbers of addresses in memory, instead of representing them by showing very hard to read base 2 numbers, we show them representing them as easier to read hexadecimal numbers. So what is a hexadecimal number? Well, a hexadecimal number is simply a number in base 16. So it has 16 digits that we can work with. We have the digits 0 through 9, just like base 10 does. But what happens past 9? Simply, past 9, we are going to start using characters from the alphabet. So if we wanted to represent 10, we would have A, 11 we would have B, 12 is C, 13 is D, 14 is E, and 15 is F. So if we look back over here, we can see that hexadecimal has the digits 0 through 9, which map back to binary, and then they also map back directly to decimal. But what happens after the digit 9? Well, to represent the number 10 from base 10 or decimal, we are going to simply put an A, and that will represent 10. If we wanted to represent 11, that would be B, and that would be the same thing as saying 11. Some other notable ones would be 12, 13, 14, 15, and 16. Well, for 12, we have C. For 13, we have D. 14, we have E. And 15, we have F. But what happens here when we run out of digits? Well, as in with the case of binary, when we ran out of digits here, or in decimal, where we ran out of digits here, we are going to add a digit place, so a 1 here, and then we are going to reset the digit places to the right. So we have 1, 0, that is going to represent 16, and then if we wanted to do, say, 17, well, that would be 1, and we would again start incrementing from here. So 1, 1 would be 17, and then 18 would be 1, 2, so on and so forth. So coming back over here, we have 63, which would be 99, and then 64, which would be 100, and 65, which would be 101. But what happens when we get to something like FF, which represents the number 255? Well, as we have been doing, we are going to add another digit place and then reset the digit places to the right, which would represent the next number, which is going to be 256. And then we can continue by incrementing the 0th place until we run out of digits, and then increment this and reset over here and continue on. And that's a basic rundown of decimal numbers, binary numbers, and hexadecimal numbers. And that is all I have for you for this video. Thank you so much for watching, and I'll see you in the next one.